Hey guys, welcome back from break. Hope you had a great break. Um, I'm, yes, that's right. I'm fresh faced today, no filter. That's right. I'm going all natural for you because I'm here on a Sunday to teach you about photosynthesis. All right, but we're going to start out kind of with the CER type question. Why are plants green? Why are plants green? Does anybody have an idea why plants are green? Well, there's a couple of reasons why plants are green. The first being that um, we get from our sun, so let's take a look at our sun here. Our sun, which is the source of 99% of all life on Earth. This is where it all begins with our sun. And it produces the entire spectrum of visible light. So red, orange, yellow, green, blue, indigo purple, um, indigo violet, I'm sorry. So we don't have violet on here, but we have all the other colors from the spectrum, which are all produced and they come shining down. Now, when they hit the plant is green. So all the other colors, excuse me, let me try that again. All the other colors that are not green absorb into the plant. All of those colors absorb into the plant. So what is reflected? The only thing that's reflected is green. And that's why we see green when we look at a plant. Now, what makes it green, that's a different story. So I thought I would start out by telling you, I know we're in the Orca unit and you might be thinking, what do plants have to do with the Orca unit? Well, actually they have a lot to do with it because without plants, there would be no orcas, even though that they are carnivores. All ecosystems, or I should say 99.9% of all ecosystems on Earth, start with the sun giving energy to plants and then plants supporting the rest of the ecosystem. So here in this ecosystem food web, we see hawks, owls, foxes at the top of the food web. They're going to consume these middle layer consumers, which all consume the producers, which are the plants. So if you don't remember, in science, we call plants producers. Now, here's the same ecosystem represented as a trophic pyramid instead of a food web. So the word troph actually means eat or consume. Okay, so this is a trophic pyramid, and this shows us what's consumed. So the right here, the herbivores, they're going to get their energy from the bottom layer, which is the producers. And then they will give energy to the next layer up, which gives energy to the next layer up. So this is a trophic pyramid. This is the same thing we see here in a different representation. Now, speaking of trophic, we actually have a special name for plants besides producers. Yes, they are producers. Absolutely, they're producers. But we also call them autotrophs. So here, when we think of the word auto, I don't want you to think of automobile, although that is just basically um, a vehicle for one person. But auto, think of it as the prefix that goes with autobiography. What does that mean? In autobiography, auto means self, right? So an autotroph is something that eats itself or feeds itself. Here we have autotroph, and then everything that's not an autotroph is actually a heterotroph. And hetero, believe it or not, means different, okay? If you have a heterogeneous group, you have a group of different type of people. That's really ugly handwriting, I'm sorry. Or if you have heterosexual, you have a couple that is made of two different sexes, a male and a female, right? Be mature, guys, be mature. Okay, so heterotroph means they have to go eat something different to get energy. They cannot get energy from themselves the way an autotroph can. So look at this picture and we can see autotrophs, they make their own food inside of their body. They don't have to go anywhere to get food. And heterotrophs, they have to consume other things, different things to get energy. Now, think about this for a second. What if you got hungry for, let's just say you got hungry for pizza. You were just craving a cheese pizza. And you were like, man, I really wish I had a cheese pizza. And instead of having to go get it or having to call out and have somebody different bring it to you, you could just make it right inside your own body. Wouldn't that be like so satisfying? You just, that was delicious. Now I'm full. Now I can move on with my life. Well, that's what plants do. They're autotrophs. When they get hungry, if they have the right ingredients, which are, there are three, they can just make the food inside of their body. And the food is actually more like sugar than anything. So it's kind of like they're eating candy. Very cool, right? So that's the difference in an autotroph, an organism that makes their own food, also called producers, and a heterotroph, which has to go outside of its body to get food. And those are also called consumers. Now, if you go to the Fred Meyer up the street and you go into where all the plants are that you eat, like fruits and vegetables, what is that section of Fred Meyer called? It's called produce. Produce, as in they produce their own food. They are producers. We are the consumers. We are the ones who go out there and buy it so that we can eat it. And that's because to survive, everything that lives on Earth has to have some kind of source of energy. Now, there's lots of different types of energy. Heat energy, which is also called thermal, okay? Radiant and light, which are essentially the same thing. We could have solar energy, which is radiant energy from the sun. We can have light energy, which is made from an artificial light source or a natural light source like the moon or stars. There's mechanical energy, which is basically like the energy of movement. There's gravitational energy, which is what keeps us from flying off into space. Electrical energy, which is mainly made by fossil fuels. We'll come back to that later. And nuclear energy, which produces energy through fission and fusion of nuclear particles. And then the one that we're really going to talk about today is chemical energy, because chemical energy, believe it or not, is how we survive. Now, you might be thinking, what do you mean chemical energy is how we survive? Well, chemical energy is when you eat food. That's important. You have to have food to be able to survive. You break down the food into smaller pieces, which your body is able to absorb. That's not the only kind of chemical energy there is. When you fill up a car with gas, what you're actually doing is putting a chemical compound in there which breaks down and then produces energy for the car to move. So it's taking what you give it, breaking it apart, and making energy. There's also, excuse me, chemical energy in things like fire. Anytime light or heat is produced, that's a chemical energy. Batteries are actually chemical energy, and fireworks are chemical energy. So there's all these different types of chemical energy that is used on Earth, and one of them is food made, or excuse me, ingested by consumers. Okay, so let's keep moving here. Now, as I said, or maybe I didn't because this is the 15th time I've recorded this, but the sun is the source of 99.9% of all life on Earth. If the sun were to just extinguish, blow up, go out, first of all, it takes 8 minutes for the light to get from the sun to the Earth. But within those 8 minutes, if that went out, that would be when 99.9% of all life on Earth would begin to die. Because why? Because all of these things rely on what? Rely on the producers or the autotrophs. If they don't make food for themselves and survive, then none of these guys will survive. And that means none of these guys will either. All right, so we talked about the different types of chemical energy. Now you might be saying, what do you mean it breaks it down into different pieces? And that's how we get it into absorb into our body. Well, let's just take a look for a second at the periodic table. Now, I know most of you are not familiar with the periodic table, but it's really not as scary as you might think it is. And it's actually made up of what in middle school we learned. It's made up of three different sections. There are the metals. All of these things are metal. There are the non-metals, which are over here, and then this little blue section, which we call the metalloids, which means that they have some characteristics of metal and some characteristics of non-metal. Now, to make this a little clearer, I'm going to show you a slightly more advanced kind of type of, okay, hold one moment, please.